We give the name first. And at this frequency to be simulated, this should be very specific because shortwave has very narrow bandwidth. So I use a frequency that I frequently use. For example, 7.07 megahertz. And we set first here the ground is not free space, is not perfect. It is a real ground. We should set ground setup here. For the electric, I use value of 5 and for enter. And for conductivity, I use value of 1. You could see how to set this value at this MANANA GAL manual. These values for suburb and industrial area, assumption of where this mobile antenna is going to be used frequently. Click OK. And the height of car roof, for example, 1.65 meters, and with material used here, I assume copper wire or ferrum wire. Okay, let's draw the antenna. The whip is going to be placed at the Z-axis here. For example, you are going to use former 2 meters band antenna whip. For example, the length is 1.25 meters. So click new wire here for new wire. Start it from the join of this Z and X axes. .25 as the replacement of car roof. I use here for ground planes. Its ground plane length for 7 megahertz band is around 10 meter. So we are going to draw 4 here. New wire. Okay, the whole antenna will look like this. If we zoom here, okay, you see here the shorter whip part at the top of foreground planes as replacement of car roof. Click OK. We could accurate the whole dimension on this geometry menu here. Okay, the whip length is not really accurate. This is 1.3. We should change this to 1.25 meter. Enter. And radius is half of diameter of the element is 0.65 as what the hip radius. To test or to simulate the SWR for these dimensions, you need to add pulse here. I use W1B here. You could see how to give this variable at the manual. This stands for wire 1 at the beginning. Pulse is going to be given at wire 1 at the beginning. Enter. Let's calculate for this specification. Start. And the SWR here is quite high, 23,932, and impedance value here consists of two parts. First one is the resistance here, and the last part is the reactance. Showed here 4.38 ohm minus J 2290 ohm. Minus J here means this antenna has capacitive characteristic or too short, need to be lengthened, or needs to be added by loading coil here. The correct impedance value here should be 50 ohm plus minus J0. There is a calculator tool here to help. for reactance of 2290 90.07, same as here. The compensating coil need should be 51.552. This should not be ohm here, should be programmed by microhenries. Value is 51.552. Okay, so at the issue at the loading coil here, we had here load W1B1 stands for at wire 1 at the beginning plus 1 step, as you should see on the manual. Enter. The compensating L from the calculator is 51.55 microhenries, and enter. And this is the Q, or quality factor, of inductance and capacitance. The average quality factor of main-made coil is 300 here. And reactance here down to minus J 226.04, but still not zero. This need to be plus minus J0, and still minus, means the loading coil value should be added. Let's try to add. Let's try. This is 56.5. 56.5. There. Right, this is the more appropriate value of loading coil. This reactance is minus J0.15 ohm. So this is this means the whip length here, if we zoom, whip length from here to here has reached its resonant length by adding a loading coil here. Loading coil at the beginning here acts as load. Now but here the resistance part of this impedance is still 13.84 ohms, and proper value should be 50 ohm. How to solve this? Let's use the calculator tool. Let's see. Okay, this is the LC mat system that we should use. There are two systems here in LC mat system, C parallel and C series. I think easier C parallel, so I choose here. The transmission line used to be used at the mobile antenna is RG58 or RG8, which the characteristic impedance is 50 ohm here, and the output should be 13.84 minus 0.15, and this is the matching system. The inner of coaxial cable should go here to the matching coil here with the value of 0.51 micro henries, and it goes to the loading coil here. Okay, and between inner and outer or braid of coaxial is short-circuited by capacitor here with the value of 727.8 picofarads. Okay, and this side goes to the outer of coaxial, and this goes to the ground, and of course the ground plane I explained before is only virtual. It could not be realized in real. The ground plane only replacement for car roof, so you don't need real ground plane at the practice. So this part goes to the ground because car roof is painted, so you should connect this to the unpainted part of your car roof.